Okay, this lesson is a little bit different in its form because it's a lot of vocabulary and kind of learning new notation, new ways to write things. And so it's a little different kind of math. And there's no reason to get nervous about it, though. It should be just fine. You'll see as we go. Okay, we're going to start out with filling in the blank here. If all the members of one set are also members of a second set, then the first set is to be said to be a subset of the second set. Okay, what does that mean? That might just be totally confusing to you, so let me show you. Let's say we have two sets. Let's say we have set B and set A, okay? In B, we have the members 1 and 2, and in A, we have the members 1, 2, and 3, okay? Now, we say B is a subset of A because everything that B has happens to also be in A, but not vice versa. So B is a subset of A, meaning all the members of B are in A. In set notation, this would be written like this. We put this sideways U, okay? That means B is a subset of A. So this is a symbol that I would like you to learn. It looks like a C, but if you look in the book, it's kind of more of a long, skinny, sideways U than a C, all right? I'll even try and do a little bit better job on my next one because mine definitely looks like a C. All right, and it looks like a C because C is what you have that you're used to seeing, not this symbol. So your brain is automatically going to associate that with the letter C that you're used to. All right, since not all the members of A are in B, see, B only has 1 and 2, he's missing 3, then B is not a subset of, A is not a subset of B. So how do we write that? A is not a subset of B. Well, it would be like drawing that symbol and then just saying not, okay? Just like when we'd say not equal to or whatever, not greater than or less than, you've seen that slash before. Okay, now let's go on. Let's let C be the set with the members 3, 2, and 1. Okay, now we go back to A also had up above, had 1, 2, and 3, and C has, I'll even write it so we can see them right there. A was 1, 2, and 3. Okay, does it matter that they're in different order? It actually does not. They have the same members. Order doesn't matter, okay? So C is the same or has the same members of A. So A and C, or C and A, are equal sets, okay? That's a kind of a new phrase. We can say that set C, this is weird, set C is an improper subset of A. What? Okay, even I am not used to this notation. I've barely used this ever since, I think, college. So this vocabulary word is, just one of those things that's a little weird, especially since we say improper subset of A. Okay, so that's another way of just saying that we have equal sets. Equal sets are improper subsets, okay? So, and we have it here. We can also say that A is an improper subset of C. So since equal sets are defined as improper sets of each other, okay? Sorry, that's a little weird, but it's not too complex. I think you can get it. The next fill in the blank here is the set that has no members, okay? There are sets later on, and you'll use it later on. Right now, it'll have no meaning to you, but the empty set. A set with no members is called the empty set, or we call it null set. The set is null, okay, nothing's in it. And this is how we write the empty set. So funny to me. Here is an empty set. Okay, I've got empty braces. Okay, just get used to that. All right, the null or empty set is the subset of every set. Okay, there is an empty set, there is a subset or is a member of every set. Okay, it's okay if this is all just totally weird to you, as long as you kind of can remember some of the vocabulary, know what an empty set is, know what a subset is, and hopefully as we apply it, it will make more sense to you. And thankfully, this lesson's like 3 pages long. Okay, going on, let's do an example with all that we've just done, okay, and see if we can make any more sense here. Okay, so I'm focusing my lens. All right, given the sets, let's say we have set D is 0, 1, and 2. Set E is 1, 2, 3, ... That means 1, 2, 3, 4, 5, never ending. Okay, on and on and on. And set G is 1, 3, and 5. Tell which of the following assertions are true and which are false and why. Okay, the first one. E is a subset of G. Okay, I'm looking at E is a subset of G. Well, that's actually false, because what that would mean is every member of E must be in G. And G only has 3 members and E has an infinite number of members, so that is impossible. In fact, it's the other way around. G is a subset of E. So we're going to go ahead and say false. Okay, and then they do ask us a lot in this section about telling why. They said, like, for example, you can tell why. 2 is a member of E, but not G. How about that? So 2 is in this set, but not in that set, so therefore this cannot be a subset of that one. Okay? All right. Is G a subset of E? All right. Are every member of G, 1, 3, and 5, also in E? 1, 3, well, since this goes on and on, this goes on and on forever, yes. We're going to say true. Okay? And again, they said why? Just say all members of G are in E. Okay? All right. Is D a subset of E? Is everybody in D also in E? At first glance, it looks like they are. However, it is false. Let's see if you can see why. Is everybody from D also in E? Oh, 0. 0 is not included in E. So we're going to say 0 is not a member of E. Sad face. So sad. Okay. Real numbers. This is now we're going to talk about the sets of numbers that we are familiar with. Okay. So real numbers, and I know right now you're like, oh, are there any not real numbers? Were there fake numbers? Well, there are imaginary numbers, and one day we'll talk about those, but it won't be this year or next year, so you're off the hook. You're fine. But real numbers, that's an infinite set because there are an infinite number of members, and basically every number that you can think of right now is a real number. So real number is like it's like the universe of numbers. It's the big umbrella of numbers, okay? So every number that you deal with is a real number. Okay, so what that means is we're going to talk about 5 major subsets. Now I have 2 listed here, and the other, or 3 listed here, and then the other 2 don't have a special letter, and I'll just talk about them. And it's all in your book. Everything I'm talking about is in your book. Okay, the natural numbers is signified by the letter N, And the natural numbers are like what we talked about when a child learns to count. They use the counting numbers, and children don't usually learn to count by saying 0, 1, 2, 3. They learn to count by 1, 2, 3. They do comma, dot, dot, dot. Okay? So go ahead and write that in there. Those are your natural numbers. Okay? The natural numbers are a subset of the real numbers. Okay? Now whole numbers, that is adding 0 to the natural numbers. So these are so close, these two number sets, except that we add 0. And now it's no longer the natural numbers, it is the set of whole numbers. However, as you can tell now, the natural numbers are a subset of the whole numbers. Okay? All right, integers, weird. I don't know why we have this weird Z to signify integers. Okay, notice I left a little bigger space here. Anything I write on here, I'd like you to write yourself as well. So this is how we do it. This means it goes on and on forever to negative infinity. Okay, we go, this is how we draw it. So it is all the numbers below 0. However, they are not fractions or decimals, okay? They jump from 0 to, there's no in between. There's no 1.5, okay? So, like my son CJ counts how old he is, not by integers, okay? Because he says right now that he is 4.5, all right? So that would not be an integer or a whole number or a natural number, okay? All right, every real number. Now, okay, so those are the three easiest to remember, okay? Now we're going to talk about the other two. We have every real number is either a rational, okay, or irrational. I don't know when you guys have heard the word irrational before, but you probably think of someone who's a little crazy. All right, well, that's not the case. When we talk about rational and irrational, what we care about is the root word ratio, okay? And a ratio is basically a fraction, okay? Rational numbers, for example, a rational number, well, every natural number, whole number, and integer are actually rational, which means they can be written as a fraction. You just might not think about it. Okay, so rational, even a whole number like 4 is a rational number because every whole number is really over 1. Okay, so that is rational. The number 2/3 is rational, negative anything, negative 1/6, you know, and so on. And decimals are irrational, okay? Because let's say I have 0.013. I don't know if you can even see that, it's so small. Can that be written as a fraction? Yes, that is 13/1000ths, okay? So these are all examples of rational numbers, all right? Irrational numbers cannot be written as a fraction. And you might be thinking, I can't think of any. Well, an irrational number like, basically pi, 3.141, you know, they go on and on and on forever. It doesn't repeat. There is no pattern or anything. Those are irrational numbers, okay? And the fun thing is that if the root of a number is not perfect, easy to find, like square root of 2, square root of 3, square root of 5, not 4, because the square root of 4 is a whole number, but if the square root is not a whole number, then it actually is a fraction or a decimal. It's not a fraction, sorry, it is a decimal that never ends, okay? So these are all irrational numbers represented by the radical sign, okay, and so on. So rational means it can be written as a fraction. So these are not, and these are. So what we're going to do is practice. Oh, the other thing is these are helpful tips. This is going to come in handy when we do an example. Okay, the product of an irrational number, something like this, or pi is irrational, anything multiplied by pi, all of those, okay? Anytime you multiply an irrational number with a rational number, your answer will always be irrational. Okay, so these are useful facts. I want you to look back at this when you do some of your homework problems, okay, if you get stuck. The other thing is when you add an irrational number to a rational number, you will still be irrational. Okay, so basically when you multiply or add with a irrational number, you will stay irrational. So I guess a rational person does not help an irrational person become rational. I guess we can think of it that way. Anyway, let's talk about some examples. Okay, we also have a new little symbol here on your paper. It looks like an E, but it's not an E. Let's see if I can zoom in better. It's an element. It's the way I read it is 1/2 is an element or a member of what subsets of the real numbers. So we're saying 1/2 out of the 5 subsets that we've looked at, natural, whole, natural, whole, integers, real, and then rational and irrational. So the 5 underneath real. Okay, so all of them are going to be members of the real number set of numbers. Okay, so this is in your book too if what I just said made no sense to you. Okay, 1/2, I can tell it's written as a fraction, so I'm going to go ahead and say it's a rational, part of the rational set of numbers, okay? The set of rational numbers. And it's the set of real numbers. But it was not a whole number, a natural number, or an integer because it was a fraction. Okay, so these are the only sets that it belongs to of the ones that we're studying. Okay, what about the number 5? What subsets of real numbers? So let's start with the more basic ones. Okay, is it a natural number? Yes. Did you learn it when you were learning to count? Natural. Okay, it's part of the natural. Is it a whole number? Yes, it's part of the whole number, set of whole number. So we're going to say natural. They call it wholes. Naturals, wholes. And then is 5 an integer? Yes, it is. So we're going to say integers, part of the set of integers. Okay, now it gets a little more complicated maybe. I don't know if that's the word I would use. So is it a rational number? Can the number 5 be written as a fraction? Yes, it can. 5/1 is the same as 5. So that means it is a rational number, okay? Or it's in the rationals, group of rationals, and it's in the reals. Okay, there you go. He got to be in every set except for irrational. Okay, well, let's do the last 2 examples. All right, 3 times the square root of 2 is a subset of what subsets of real numbers, okay? All right, so this is where I was talking about what did square root of 2 we decided was irrational. So if we multiply it by a rational number, it still will not become rational, okay? So therefore, it's not part of our counting numbers. It's not a whole number. It's not an integer. All it is irrational. Or it's part of the irrationals and it's part of the reals, okay? Let's look at example 5. Now we're supposed to true or false and why. I'll try and zip through these because I'm going to run out of time here again. Are all reals a subset of integers? No. In fact, they're on page 249. It gives you a picture. Let's see if I can find it here or should be able to show it. Okay. See this picture of kind of like a Venn diagram here of, anyway, you have it in your book. There it is, okay? So everybody's part of real numbers, but real numbers aren't necessarily integers, okay? So we're going to say false. So you just write false or F. And the reason for that is reals are not a subset of integers. The integers say reals are not a subset of integers, but the other way around. Okay, I don't know, this is an example. I might just discuss these. I don't want to have to write them all out for the interest of time, okay? Your book gives why, but I'm also going to talk about why, so I'm going to call that good enough. All right, are all irrational numbers reals? Yes. Irrationals are part of the real. Everything we talk about this year and then next year will be part of the real number, set of real numbers. Okay, so true. Are irrationals in this a subset of rationals? We're going to say false. Okay, irrationals are not members of the rationals. Okay. The irrationals are not a subset of the rationals. In fact, no irrational number is also a rational number. It is either one or the other. None of these guys are in here, and none of these guys are in here. Okay? Or girls, whatever. All right. Whole numbers are whole numbers, natural numbers. Okay, so remember the whole number set is 0, 1, 2, 3, and on and on. Natural numbers are 1, 2, 3, on and on. Okay, so is every member of the whole group in the natural group? False. But all the naturals were in the whole number set. Okay? Because of that number 0. 0 doesn't belong in here, but it does belong in here. So that means natural is a subset of whole. Okay? All right. Integers, real numbers. Like I said, everything we're talking about are real numbers. So all the integers are part of the real number family. Okay? So true. All right. The rest of this is practice, and we'll call it good. This was a slightly longer lesson just because different terminology. Okay? But give me a call or ask questions if you get stuck. All right? Or email me, and I can call you back or do more videos because these are fun. All right? Your practice is just like the examples that we did. So I want you to do them and check your work and make sure you are understanding this new material. All right.